Hi everyone, so this is the last subtopic for the Chapter 1 Method 1.3 Stoichiometry Part 2 Limiting Reactant. In this part, you will learn about the limiting reactant and percentage yield. So let's see the concept map. If you have the known substance, either reactant or product, and you also have the unknown substance, reactant or product, so it connected by the moles, which is you can use the mole ratio to get a mole of one of it. Where can you get the mole ratio? Which is use the coefficient from the balance equation. Let's say you have here the equations reactants A and B produce C and D. So the coefficients for the A is X, B, Y, and C, Z, D, W. Let's say you have mole for the A and you want to determine mole of C. So you can determine mole of C from the mole of A. And if you have mole of A, you want to determine the mole of B. So from the mole of A, you can determine mole of B. Okay, and mole is from the mole you can get the mass by multiplying the molar mass. And if you are given the mass, you can get the mole by divide the molar mass, volume at STP, to get the volume of the solutions or gas, mole times to the molar volume. From the volume to get mole, divide by molar volume. And to get the particles, moles, multiply by the Avogadro number. And then to get the mole from the particle, divide by the Avogadro number. So this concept will be used for determine the limiting reactant. Let's say you are given the mass of the reactant A. So from the mass of the reactant, you have to divide by the molar mass to get mole of the reactant. And from the mole of the reactant, you can get the mole of the B. Okay, and then by multiply the mole ratio, then to get the mass of B, you can multiply by molar mass. So that's how you can use this concept for the limiting reactant. From the mole of A, then you can get the mole of B, and then you compare. Okay, from there you can determine the limiting reactant. So let's see the example. First, you have to know what is the limiting reactant. Limiting reactant, it refers to the reactant that is completely consumed in a reaction and limit the amounts of the product form. Okay, completely consumed in a reaction and limit the amounts of the product form. Let's say you have reactants. By using the stoichiometric method, you can determine the limiting reactant. And this limiting reactant, it will limit the amount product form. At the same time, there will be excess reactant. So what is the stoichiometric method? Okay, by using the concept that I told you before in the map, so you have to relate with the equations and make sure that the equation is balanced. Calculate the mole of the reactants A and B. Okay, because you want to determine the limiting reactants, so you will be given the mass of the reactants, then you need to calculate the mole of the reactants. Okay, then you compare mole A and B, calculate the amount of the reactant B required to react completely with the A. So you compare, okay, between these two reactants. Let's say if the B available, the given B less than needed B. Needed B, we refer to the one that you calculate by using the stoichiometry method, and this is show that B is limiting reactant. If the B given more than needed, it shows that B is the excess reactant and automatically A limiting reactant. Then from the limiting reactant, you can determine the amounts of the product form. Okay, let's see this analogy. Let's say you have 4 buns, 4 pair of the buns, and then you have the slice of meat, 3 slices of meat, complete with the cheese, and you have the cucumber, and you have the onion, and you have tomato, also salad. So this is as a reactant. Okay, all these ingredients as a reactants. So how many burgers can be produced from this ingredient? There are only 3 burgers can be produced. Why only 3 burgers can be produced? There are 4 pair of buns, but why only 3 burgers form? This is because there are limiting reactant. Which one is the limiting reactant? Slice of meat. Why? Because it only has 3 slices of meat. So this is the smallest number compared to the other ingredients. So this is the limiting reactant, which is it will limit the amount of the burgers produced. So at the same time, there will be excess reactant. So what is the excess reactant? Okay, from the 4 pair of the buns, it only used 3 pair of the buns. So one of the buns will be excess reactant. Same for the other ingredients, cucumber, onion, tomato, and salad. Okay, all these are excess reactant. So only 3 burgers produced from the given ingredients. Okay, let's see this example. For the following reactions, it gives you the reactants, ammonia, copper oxide, and the products, nitrogen gas, copper, and H2O. And it also gives you the mass for the ammonia for both of the reactants, relative atomic mass for the elements, and determine the limiting reactant. To determine the limiting reactant, you have to use the stoichiometry method. Okay, let's see. First, you need to calculate the mole for both of the reactants. So this is the given. Okay, the calculated mole is the given mole. Then you compare by using the equations. Okay, from the equations, 2 mole of the ammonia react with, okay, because it is reactant, both of the reactants are reactants, so you need to use react with. Okay, 2 mole of the ammonia react with 3 mole of the copper oxide. Given mole of the ammonia here, 1.059 mole, it will react with how many mole of copper oxide? Suppose it react with the how many mole of the copper oxide. So when you calculate this value, 1.059 mole ammonia times to the 3 mole of the copper oxide, divide by 2 mole of the ammonia, and mole of the copper oxide needed is 1.5885. So this is the needed copper oxide, but given copper oxide 1.131 mole. So is it enough to react with the 1.059 mole? So you can see that mole of the copper oxide needed 1.5885 mole, more than mole of the given. It shows that the copper oxide given is not enough to react with the mole ammonia given. So means that the copper oxide is the limiting reactant because it has minimum amount given mole. So once you get the limiting reactant, from the limiting reactant you can determine the mass of the nitrogen gas produced. Same as you determine the limiting reactant, okay, to determine the mass of the nitrogen gas, you need to find mole of the nitrogen gas by using the equations. Compare the limiting reactant and the products. 3 mole of the copper oxide produce 1 mole of the nitrogen. If there are 1.131 mole of the copper oxide, it will produce 0.377 mole of nitrogen gas. This value multiply by this value, divide by this value. Okay, once you get the mole of the nitrogen gas, next you can get the mass of the nitrogen gas form is this one, mole multiplied by the molar mass, then you will get 10.56 gram. Next, determine the mass of the excess reactant remain after the completion of the reactions. Okay, how much the excess reactant remain? Alright, so by using the mole of the limiting reactant, you compare with the mole of the excess reactant. Okay, if 3 mole of the copper oxide react with the 2 mole of the ammonia, and given mole of the copper oxide 1.131 mole of the copper oxide react with how many mole? This one, 0.754 mole ammonia. It's supposed to react with this value, but okay, so you multiply by molar mass of the ammonia, then you will get the mass. Okay, to get the excess reactant remain, this value 18. Okay, this one is the given mass of the ammonia in the questions, minus to the mass of the ammonia reacted that you have calculated here. So this is the excess reactant remain after the completions of the reactions. Okay, this is how you can get the excess reactant remain. Next, percentage yield. What is the percentage yield? It is the percent of the actual yield of the product to its theoretical yield. So this is the formula, percentage yield, which is actual yield divided by the theoretical yield times 200. So let's see the example.
Percentage yield. Percentage yield is the percent of the actual yield of a product to its theoretical yield. By formula, the percentage yield equal to the actual yield over the theoretical yield times 200. The amount of the product predicted by a balanced equation is the theoretical yield. In other words, amount of the product calculated from the stoichiometry is the theoretical yield. The theoretical yield is never obtained because, first, the reaction may undergo side reaction. The reaction may produce side product. Second, many reactions are reversible. Third, there may be impurities in the reactants. For the example, you have doing the experiment 2. So, in the experiment 2, you have to weigh 0.25 gram of the zinc powder. Maybe some of the zinc powder is not pure. Fourth, the product form may react further to form other product. Fifth, it may be difficult to recover all the product from the reaction medium. So, the amount product actually obtained in a reaction is the actual yield. Okay, by using this analogy, let's say I have an order from my friend for 18 cupcakes, but I can only make 70 cupcakes because the cream is not enough for the one cupcake. So the actual cupcakes that I can make is 17, which is suppose I have produced 18 cupcakes. Example 9. If 3.7 gram sodium metal and 4.3 gram chlorine gas react to form sodium chloride, what is the theoretical yield? If 5.5 gram sodium chloride was formed, what is the percentage yield? So, it gives you the mass of the sodium metal and chlorine gas. And it also gives you the mass of the sodium chloride formed. 5.5 gram is the actual yield. First, you have to find mole for both of the reactants. Inertial mole for the sodium is 0.16 mole, while for the chlorine is 0.061 mole. And you have to determine the limiting reactant, because to calculate the mole of the sodium chloride, you need to determine the limiting reactant first. From the limiting reactant, then you can calculate the mole of the sodium chloride. So from the equation, 2 mole of the sodium react with the 1 mole of the chlorine. Given 0.16 mole of the sodium react with 0.08 mole chlorine. This is the needed chlorine for the 0.16 mole of the sodium. So, mole of the chlorine needed 0.08 mole is larger than mole of the chlorine given 0.061 mole. And chlorine is the limiting reactant. Limiting reactant, it will limit the product form. So from the limiting reactant, you can calculate the mole of the sodium chloride. From the equation, 1 mole of the chlorine produce 2 mole of the sodium chloride. And given mole for the chlorine is a 0.061 mole, produce 0.122 mole sodium chloride. Then, find mass of the sodium chloride by times its molar mass. And the mass of the sodium chloride is 7.137 gram. This is the mass for the theoretical. Then, by using the formula percentage yield, so you substitute the actual yield, 5.5 gram is come from the question, over 7.137 gram you have calculated just now. times 200. So the percentage yield is 77.0%. Okay, let's see the example 10. A sample of impure magnesium was analyzed by allowing it to react with the excess HCl solution. After 2.95 grams of the impure metal was treated with the 0.15 liter of 0.75 molar HCl, 0.0514 mole of HCl remain. Calculate the percentage of magnesium in the sample. So it gives you the mass for the impure metal of the magnesium, and it gives you the molarity of the HCl, volume of the HCl, and mole of the HCl remain after the reaction. Calculate the percentage of the magnesium in the sample means that it needs you to calculate the percentage of magnesium from the impure metal of magnesium. Okay, this is not calculation for the percentage yield. Okay, this one, it needs you to calculate the percentage of magnesium in the impure sample. First, you have to form an equation for the reaction, which is magnesium react with the 2 mole of the HCl, produce 1 mole of the magnesium chloride, and release hydrogen gas. So mole of the HCl, okay, because it gives you the molarity and volume, so you can calculate the mole of the HCl. It is 0.1125 mole. While mole for the HCl reacted with the magnesium, mole of the HCl 0.1125 mole minus to the 0.0515 mole. That one is the mole of the HCl remain given in the question. So it is 0.0611 mole. From the equation, 2 mole of the HCl react with the 1 mole of magnesium. Then 0.0611 mole of the HCl react with 0.0306 mole of magnesium. Okay, so 0.0306 mole of magnesium is the mole of magnesium that used to react with the 0.0611 mole of HCl. So mass of the magnesium used to react with the HCl is 0.744 gram, and the percentage of magnesium in the impure magnesium, okay, 0.744 gram over 2.95 gram is the mass of the impure metal of the magnesium times 200. So the answer is 25.2%.